Okay, so this when you go to edit, right, this is one of the I would say kind of like a new feature that we have actually lah. So we actually have all this graphics that actually comes out and show. Last time in SEO we don't really have this graphics. Okay, so you actually from here you can actually select the kind of chiller that you want. Is it a constant flow, step flow, variable flow, or the couplet system? Okay, so it also has the add and subtract method that you can actually define. So you're going to tell it like what kind of like configuration it's going to be, how many numbers of chillers. Okay, so this is the standard graphics that is actually built in. Okay, okay, so when you have a chiller plant being created, right, there's always going to be a chiller plant enable point. Okay, so yeah, you have to tie this chill water plant enable point to one of your it's either you can create it as a BO or BV point. Okay, you have to tie this chiller plant enable such that the user can actually override this thing. Okay, so that's why they can actually override whether they want to disable the plant or enable the plant. Okay, so usually we will have this tied to a schedule as well, because not all job sites operate 24/7. Some buildings maybe just a normal office building. Okay, so for those case, right, they may have a fixed operating hours, maybe from 8 to 7, 8 a.m. to 7 p.m. So that's where you will use this chill water plant enable point to be a member in the time schedule. So you can actually set the daily operating hours. Okay, so once the schedule operating hours is fulfilled, right, the operating time at 8, right, then you will call this to be enabled. So after 7 p.m., right, based on the schedule, it's going to just disable the plant. Okay, so the next important thing that you need to tie on is what we call the system chill water set point. Okay, so you need to know what is your chill water design set point. Okay, then you have to tie the physical point over here. So this set point can be changed. Okay, so you can actually override this set point, okay, by the user, but we do not recommend users to change all this, because when people do overriding, right, they will tend to forget to release the command. So when that happens, right, it's going to affect the operation, because this chill water set point is going to determine how cool your chiller is going to produce the water. Okay, and also when to call the next chiller to come in when there's an add requirement. So if let's say you change this to a very high value, let's say if the user override to 10, right, then yeah, this is going to call your chillers. If you tie this system chill water to your chiller set point, it's going to call the chiller to run at 10 degree. Then also your air conditions, all this will also be changed accordingly also with reference to this system chill water set point. So this is also a very important parameter that we do not really want the users to override. Okay, so when you actually hand over the system to your clients, right, you have to tell them that try not to make changes to these things. Okay, so you also have to tie in your system chilled water supply temperature as well as your system chilled water return temperature as well. So that can be from your high accuracy sensor if you have, okay, or just a normal temperature sensors that you have on the supply return pipe work. Okay, so over here you also see these rotate chiller. Okay, so this rotate chillers, right, it's you can also do a force rotation. Okay, users can always like force rotate chillers. So when you click on rotate chiller, right, this screen is going to pop up. Okay, so you can actually see what is the current sequence number. Okay, so let's look at sequence number. Just now we talked about sequence number. So CPC itself, right, the nature is that it's always going to call the smallest sequence number to start first. So in this case, it's going to call chiller 1 to run. Why? Because chiller 1 is sequence number 1. Then if the load increases, the next chiller is going to call is the sequence number 2, okay, which is chiller number 2. So it's not necessary that you see here chiller 1 is 1, chiller 2 is sequence number 2, chiller 3 is sequence number 3. It's not always in this manner. Okay, so you actually rotate the sequence number, it will also change. But for now, it's actually chiller 1 to sequence number 1. So whenever it's enabled, right, it's going to call chiller number 1 to come in based on sequence number, because there's no base chiller being defined for this plant. Okay, so all of them are normal chillers. So if chiller 1 fails, right, then the next in line, which is the next sequence number to call in, will be number 2. So always remember, when you call chiller to come in CPC, smaller sequence number comes in first. But for subtract, we will always look at the larger sequence number. So the larger sequence number will be the first one to be called out. So when you rotate chillers, right, this is the current sequence number. Okay, 1, 2, 3, 4, right? Sequence number 1, sequence number 2, sequence number 3, sequence number 4. So we always can change this one. So that's why I say sequence number may not necessarily tie along with their naming. Okay, so we can actually rotate chiller 4 to be the first one, sequence number 1, and chiller 1 to be sequence number 2, followed by chiller 2 in the third sequence number, and finally the fourth one to be chiller 3. You can actually do a rotation. Okay, so when you rotate, right, the sequence number is going to change. Okay, yeah. So just now we changed chiller 4 to sequence number 1, right? Remember, just now we did a rotation. Okay, and chiller 1 to be sequence number 2, followed by chiller 2, lastly chiller 3. So sequence number will not be according to their name. Okay, it will always rotate based on the rotate conditions that you have. Okay, so you can also tie this chiller sequence rotation, this point, to a time schedule such that it can be rotated on a weekly basis, okay, or every couple of days. It depends on your requirement. Okay, so over at this status page, right, you also see the current operation of what the CPC is asking to do, as well as when the chiller will be added and when the chiller will be subtracted. Okay, so for now, because our controllers are offline, okay, so that's why you don't see any chillers available to be added. Okay, so you also have the alarms. Okay, so the alarm page will actually capture your chiller failure. Okay, so whatever chiller failure alarm that you actually have, right, it will be captured here. So it can be very different description. As you see here, right, some is because of COM loss, okay, and then you also have failed to confirm running. So whenever CPC asks a chiller to come in, right, let's say I ask chiller 1 to run, okay, so it will actually call the valves to open. It's a sequential order lah. You always start from your cooling tower, right? So after your cooling towers are run, you will check that your pumps are actually running, your valves are also open before it sends a start command to the chiller. So once CPC sends a start command to the chiller, and then it doesn't come back with a feedback status. Okay, so for example, the chiller already called for a start command, but 5 minutes have passed. The chiller is still not running. I don't get a chiller status feedback that the chiller is running. It's not on. That's where you have a failed to confirm chiller running. So it actually goes through the check. So once it calls for a start and the feedback doesn't come back, right, then it will fail the chiller. So that's why you have a fail to confirm chiller running. Okay, so when this alarm occurs, right, in your status page, right, the chiller failure is going to say fail to confirm chiller running. Okay, it's going to mark this chiller as a failure. Okay, you need to do a reset, which is why you see a chiller pump reset required. We will fill this chiller, then you will call the next sequence number to come in to take over as a duty chiller. Okay, so that's fail to confirm chiller running. Okay, so fail to confirm chiller off is also alarm that will be generated as well. Okay, so whenever there's a failure that happens, right, then you will need to come to the chiller and then you have to do a chiller reset. Okay, when you see a reset, when the alarm, remember just now we saw chiller plant reset is required, then you have to come in here and do the reset for the particular chiller. Okay, just check on the box and then after that reset the chiller failure. Okay, so you also have your data log. Okay, so usually data log we will actually set it in the normal data logs itself lah. So you can actually enable all these points to be logged as well. Okay, so function is where we have add and subtract. Okay, so whether you have a add request and also a subtract request. Okay, for the calculations here, right, we don't really use this feature. Okay, so if you want to see this feature, more details of this feature, then you reference back to your chiller plant application guide, okay? But it's not a usual practice for us to use this lah, okay? So the configuration part, right, is where you actually tie your physical point. Okay, just now what you saw here, you have your chiller plant enabled, right? It's all done in the configuration view. So you actually see this button with a globe, right? You can actually click on this, and then you can select the points that you want to tie this point to. Okay, so you can actually tie these to the point that is required. Okay, same goes to the system chill water set point. Okay, you can actually tie to the variable point that you actually create as well. Okay, so chiller start interval. What is this chiller start interval? Okay, so this start interval, when you see in this example, is 5 minutes, right? It means every time when there's a chiller that is being started, right? Okay, once another new chiller is asked to call in, once the chiller has started, right, it's going to enter into this, we can say there's a hot mode, right? So during these 5 minutes, right, nothing is going to happen. It's not going to add another chiller. Neither is it going to allow you to shut down another chiller. That's why it's going through this start interval, because you want to let the new chiller that's being cut in to stabilize. So it actually goes through this chiller start interval. Okay. Then you also have the shutdown delay time as well. Okay. So just now I was saying that we don't really use the ambient temperature lockup, but if you want to read a little bit more on this, right, you can actually go through the chiller plant application guide as well. Same goes to your soft start. Okay. So rotation, right, you can actually do it based on the rotation that you fix here, or you can actually input it into a rotation input. Okay, you can tie these to a point that you can tie to a time schedule itself. Okay, for this example, it's just going to use what is on board, and it's going to fix it on a certain day. Okay, but for some cases, right, we might just want to do it based on a time schedule, a separate time schedule that's on your schedule page. Then you can actually tie it onto another set point. Another physical binary point. It's just the same thing. You can just reference it to any of the points that is inside your what you have created. Okay. So next, you also have the add subtract. Okay, we'll be talking about add and subtract, right? Because you need to know when CPC needs to know when to cut in another chiller and when to cut out the chiller. Okay. So for this, right, usually for us, right, we would usually we don't really use the onboard feature. Usually we always do our own program to cut it out. So that's why you see that we actually reference it out to an external point. Okay, so this example is actually reference out to a binary value called CPC add. Okay, so for subtract is also tie up to another value called binary value, which is the CPC sub. Okay, so these conditions are actually points that we write separate TGB to check when to add and subtract. Okay, if you don't use this, it's also fine. Then you'll be using what is defined as per what you're going to add in over here, which is based on CPC logic itself. Okay, so it's not compulsory for you to actually tie it to an external reference point and write your own TGB. Okay, it's not compulsory. So it's really up to the design. Okay, so here, right, when we talk about add delay, when you put 20 minutes here, it means that the condition has to hold true for the 20 minutes. So if the condition doesn't fulfill, right, it's going to reset the counter. Then it has to reset and count again and fulfill the conditions of 20 continuous minutes. Okay, before it actually calls for add condition. So similarly with your subtract, right, when you put a delay timer of 20 minutes, right, it means that your subtract condition, whatever you have actually wrote in your program to activate this point, it has to fulfill that 20 minutes. Okay, so here when you use this desired average capacity of the subtraction to be 80, right, it means the remaining IRA of the remaining chiller will be 80% of the capacity. Okay, so that's your add and subtract. Okay, yeah. So when we come to members, right, is where we assign the chillers. Okay, so usually for us, right, we actually tie these not to the chiller. Sometimes some of us may actually tie these to our controllers, which is what we call the UC600. Okay, so it really depends on how the local officers actually use your CPC feature. For us in Singapore, right, usually these are our UC600. The chiller names here you see is actually our UC600. We actually tie them to a point in our UC600. Okay, so when you have your individual chillers or your individual controllers, which you define here, okay, based on the configuration on site, you have 4 chillers, then you do 4 over here lah. Okay, so you actually you will actually tie these conditions. Okay, so actually we can see, oops, maybe I shouldn't show this. So we can actually edit the configuration. So chiller 1, right, you have to set your chill water minimum set point, okay, and then what is your unload current limit that you want to do the unloading. Okay, that's also with reference to what we are saying, the RRA itself. Okay, so you can actually enter your chiller design capacity, okay, and whether you're going to use this CPC to call for another chill water pump output. Okay, it's not necessary to activate this point, but for some jobs, right, we actually use this to call as a point to call our chill water pump to trigger in our TGP. Okay, so if you are going to make use of this, right, then you will tie it onto your UC600 point, which you reference to a chill water pump output coming from the CPC. Okay, so this is where you define whether you want this chiller to be like a base chiller. For example, I want chiller 1 to be base chiller. Okay, then I want chiller 4 to be the peak chiller. It's going to be the last chiller to run. Okay, you can also do this. Then for here, right, is where you will actually tie chiller lockouts over here. Okay, so we can actually tie the chiller trip point from the UC600 to the chiller lockout here. So every time when there's a trip received, right, you will lock out this chiller. Okay, if you actually tie the point here. Then whether you want the thing to auto reset, okay, usually we don't really enable the auto reset because we want the user to know that there's a failure and they have to actually act on it and do a failure reset. Okay, so this is whether you want to verify the chiller is running, okay, when the chiller starts. Okay, this is recommended to put as enabled. Okay, then you also have a chiller failure input. If you actually have other programming logics to check, you can also tie these in as well. So sometimes, right, we will also check whether the selector switch of that chiller equipment at the MCC panel, or you call it the control panel. Okay, the electrical panel side usually have this selector switch whereby you will put it to, I think the syntax is usually, it's either auto or BMS. Then you actually have local or manual. Then there's also a state which is called off. So as long as it's not within auto or BMS mode, right, the selector, then you also want to mark that chiller as a lockout. Then you can actually tie those points in as well. Okay, it's all going to be scripted in your TGP tool itself. Okay, so the rest of this it's not necessary to fill in. You can choose not to enter the evaporator flow rate point and the unit power consumption. You can don't bind this point. It's fine. Okay, so whether you want to fail to confirm the chiller, okay, fail to confirm chiller flow, you want to enable this, it's up to you. Okay, you can also tie these out to an external point. Okay, so these are points that is actually you can actually decide whether you want to fill the conditions based on these conditions or not. Okay, if you don't get like a chiller running status, right, you want to fill this, then you enable it. Okay, yeah, then we can click finish. Okay, so just now we actually set chiller 1 as the base, right, and chiller 4 as the peak. So that's why you see every time when the CPC starts, right, it's always going to call chiller 1 already once you assign this as a base chiller. So chiller 4 is always going to be the last chiller to be cut in because it's designed as a peak chiller. Okay, so the rest of this I think if you have any other things that you want to import in, then you can actually make use of the support features lah. Okay, so this is just the detail view is actually just a view of the CPC itself. Okay, yeah.